There are a total of num causes. You have to take label from 0 to nums causes minus 1. You are given an array prerequisites where prerequisites I values equals to a I bi indicates that you must take bi first before if you want to take cos a or so in this case we have to in order to take this we have to take this first. For example, the pair 1 indicates that you have to take the cos 0 or that to take a cos 0 you have to first take cos 1. So here in order to take this we have to take this first. Return true if you can finish all causes, otherwise return false. So in this example we have num causes, which is 2 prerequisites 1 0 and we have true. There are a total of 2 causes to take. To take cos 1 you should have finished cos 0. So it is possible. And in this example we have the same causes as we had before, num causes, so 2 prerequisites 1 0 and then 0 1. So it's false because there are a total of 2 causes to take, which is here. To take cos 1 you should have finished cos 0, and to take cos 0 you should have finished cos 1. So it's impossible because it's saying to take this first and then now this one saying to take this first. So it's impossible, so we have a false with this. So this is a graph problem. We can use adjacency list for our graph representation, and then so we'll do that by naming our list graph and put a list empty list for empty for node or whatever, and the range of num causes. And then once we have this, let's make so let's take a pre cause and cause to represent our intended cause and its prerequisite curves. So that we will add that to for cars and or pre-cars in prerequisites, which is this over here. Let's take a graph and then make precurs. Put our precurs first, precurs, and then append cur cars, cars will be dependent dependent on precause. So once we have that precause, let's take our, let's create our markings, to track cycles, visitations to check for cycles. So markings, so 0 will be equals to unvisited. 1 will be visiting. 2 will be visited. So let's do that by creating a mark variable and then a 0 value to and then multiply it to every nums classes. So now let's create our DFS to traverse the graph. So now once we have all these DFS to traverse the graph, DFS, and let's make our cause our parameter. So now if mark the cause value is marking, so we give it, so since we're starting at 0, it will not apply yet. So let's just do a 1 return false, which is visiting. If mark cars is equals to total visited, return true. So now let's go down and make mark cars equals to 1. So once we do this, these two will not apply yet. We'll give the current cause that we're on, this one. So now let's check for the neighbor of the causes. So for the neighbor in our graph, graph of the graph for the neighbor in the graph cause writes if neighbor not DFS so if the neighbor is not is false, neighbor, if the DFS of neighbor return false, and then once let's move out the loop and name, let's create a marking cars is equals to 2, and then let's return for true if return true. Oops. True. So once we get past all of these, and none of these are true, so the course that we're on will be counted as visited. So now let's move out of this DFS function to check for courses. Check courses loop. So for I in the range of num neighbor no sorry num courses read if neighbor if if mark I is equals to comparison 0 and not meaning it's false, the DFS I is false. DFS of I, so for every I it will check the neighborhood. Return false if it's unvisited. So for example here it will check here this and this, so it will start off giving it 1 and then check its neighbor, which will be which will not be false. So it will be given true, which is true. And let's move out. Return true if all of them are. Let's see if there's something that needs to be fixed here. Current for in range courses. Current course, requisites, pre-course, current course, current courses, market course, That should work perfectly. Let's see if it does, if it has any syntax errors. Invalid if neighbor. For neighbor in graph course, if not. Let's see if that's fixed now. And that's it. It works perfectly now. And let's submit it to see if it's going to pass all cases. And it's been able to pass all cases. So this, in this case, time and space, complexity is both of the vertices plus the edge. And that's it for this problem.